Hello friends, we will now begin the introduction part 2. In introduction part 2, we will majorly cover the open loop and closed loop control system. In part 1, we discussed about the basic definitions of control system and then the classification. In open loop and closed loop control system, this type of classification, that is open loop and closed loop, is based upon the control action. So, how do you define an open loop control system? In the block diagram process I have drawn, it is that a system in which the control action is totally independent of the output of the system. Okay. We are not to know that what is the output of the system, that is the action, whatever the process is happening is giving us an output. We will take up some examples. So, we have a reference input, there is a controller and that is fed to the process, and the control output that is received. So, there is nothing that is being sensed and fed back to the input to understand that some desired change is required. So, that is not been done in open loop control systems. In open loop control systems, we have a reference and the output is done. Now, for example, how do we understand an open loop control system? We can see that an electric hand dryer. How does an electric hand dryer represent an open loop control system? Now, your hand is being dried, irrespective till your hand is below the blower, then there is an hot air, but irrespective of whether your hand is dried or not, then such type of systems are control system, because the output is not being sensed, the output is just given, that is the response is once the hand has been below the blower, it has to blow dry air, and the irrespective of whether your hand is being totally dried or not, till your hand is below the dryer, it will continue. So, such is the open loop control system example. Another example is our automatic washing machine. Now, we put into the clothes and the clothes dry and come out, but irrespective of the washing is completed or not, that is the preset time is given, that the washing machine will run for a particular time, and not about the kind of clothes being put up, it is only decided by the time, till what time the machine will run, a preset time. So, this is an automatic machine, whether the clothes is being properly washed or not, that is not sensed. So, it is an open loop control system here. The water input, the speed for spinning, and all these are the inputs, but the output is not being sensed whether there is some changes required or not. So, such system that is a washing machine comes under a open loop control system. Another example is a bread toaster. The machine runs as per again a set time, that is we are not having any reference whether the bread is being toasted or not, but for a preset time the completed work is done. So, whatever the output comes out, that is the response of the process, that is heating of the bread. So, such systems are also the open loop control systems. Again, an open loop control system which we day to day use in our life, that is a tea coffee vending machine. That in machine also functions for a pre-adjusted time. Now, if the system is functioning for a set of time, that is desired set of time, irrespective of being checked what the response is, then those systems are all open loop control systems. Some more examples, light switch. When you switch on the light in the room, the light remains on till it is been switched off by a particular person. So, it is an open loop system, or the same thing if now it has been if we sense that there is no person in the room and then the light is automatically switched off, that becomes a closed loop control system. But if the switch if the light remains on in the system, even if the person is not in the room, then it becomes an open loop control system. Traffic light system is another well example. In traffic lights, what happens? The green, red and the yellow lights glow with a preset time, but it is not the output is not been sensed here, that if the number of vehicles towards one end is more and the other end is less, so that the preset time changes for particular direction, that is not been sensed. It is only that the green light glow for some 60 seconds or 10 seconds, and then the yellow and the red light. So, if it is the traffic lights function for a preset time, that is well decided time, then those systems are all open loop control system. Why here? Because irrespective of the amount of vehicles at the traffic signal, the green light will be on. Maybe at after 10 seconds there are no vehicles moving from one direction to the other direction, but the light is still green, because the traffic towards that end is not so heavy as towards the other end. So, but as the system is preset for a particular time, that is 60 seconds, it will keep being glowing as a green light, green signal, whereas the other direction where the number of vehicles are more, that is still in the red signal. So, such systems are open loop control system. Some of the advantages of open loop control system. Once we understand this advantages, then we will switch towards the closed loop control system. One is that it is very simple in construction and design, because we are the major part is the output is not being sensed, that is output is not sensed. So, output is not sensed. So, in that case the major designing becomes simple. We are not using any sensors to sense the desired output, and therefore, the simple construction becomes very simple, and of course, the components are less, therefore, it can also be termed as economical, easy to maintain, and generally because we want the systems to be stable. In closed loop systems, stability is a major issue, because the output has been sensed and then manipulated variable has been fed. So, therefore, open loop systems does not have a major issue of stability, and convenient to use, as the output is convenient to use, as output is not difficult to measure. The accuracy part is a concern in case of open loop systems. Normally, things are not sensed, that is output is not been measured and fed back to the input for comparison. Therefore, there is a high chances of being the output inaccurate and unreliable, and any change, this is the thing, any change in output cannot be corrected automatically. So, this is this comes as a disadvantage of open loop control system, but in comparison it is very economical as well as simple in construction, because the number of components are less. Now, let us see what is a closed loop control system. Now, a system in which the control action is somehow dependent on the output. So, if the process is been controlled, then it becomes a closed loop control system. So, we can see in the block diagram here, there is a reference transducer, that is the input side. This is the input, this is the reference input, this is the reference input. Reference input is from the transducer, that a particular pressure value has to be set, or a particular temperature has to be set in an industry, and that is the reference value being given. Now, this controller, what does this controller does? Once the process has been completed, whatever output has been obtained, that is now fed back through a feedback transducer, any feedback element, and then this feedback signal is sent to the error here. Now, this reference input and the error, this is E error signal. Error signal is being fed to the controller. What difference was been from the reference and the output signal, that is our E of t is the difference of R of t and B of t. This is the feedback. The feedback signal is compared with a reference, and then the error signal is fed to the controller. The desired action is taken place here. Desired action is taken place with the controller and the manipulated signal. Now, the original signal is not fed, the manipulated signal is fed to the plant. This M is the manipulated signal, and this process is with involving feedback. This process which involves the feedback, that is we are looking at and what is the output and feeding it back to the comparison. So, such systems are the control system. This is the forward path and this is the back path. So, this is the back path and this is the forward path in this particular direction, and this is the feedback in the module. All those systems which have a feedback loop, that is sense the output and compare with the reference input, fall under the category of closed loop control system. Okay. So, there are many components in comparison to the open loop control system. The number of components have been increased here. We are now comparing the output signal with the desired response with the output, and if there is a difference, that error is fed to the controller, and whether a proportional signal or an integral or a differential signal is sent to the plant again, and then the output is again compared. So, this process which involves a feedback path all comes under the category of closed loop control system. Now, let us see for example here, there are many examples. Now, one is the aircraft landing system. Now, we can see that the three major components of aircraft landing system is the aircraft itself and a radar unit as well as the transmitter. Now, what is the function of a radar unit here? You have a controlling unit as well. The vertical and the horizontal position of the aircraft is being sensed with respect to the ground, that is sensed by the radar unit, and it has been fed to the controlling unit. Then the command which is required is sent to the transmitter, and this transmitter sends back the signal to the autopilot in the aircraft, and the response is thus landing of the aircraft. Now, if there is no feedback signal about the position of the aircraft, then the aircraft will land and that becomes an open loop control system, but that is not possible for an automatic aircraft landing system. In that case, definitely the position vertical and horizontal position of the aircraft from the ground has to be sensed, and then the command, that is the two major commands, that is the pitch and the bang commands are calculated and sent back to the aircraft. Thus, these commands are then transmitted by transmitter to the aircraft to respond for the landing purpose. So, this system is now a closed loop control system, because the output that is been fed back to the aircraft. Now, another example here is an automatic electric iron, where the drying of the clothes, for the drying of clothes, the heating elements, if the clothes are not dried, that is sensed back, and the heating elements are heated for more time, so that the clothes dry. So, such system falls under the category of closed loop control system. Now, another example as traffic signal example I also covered in the open loop part, but in that case as we compare now a traffic signal to an open loop and closed loop system. Now, there if the signal is on for a particular preset time, then it becomes an open loop control system. But if the signal, that is the green, red and yellow light, are not preset, but dependent upon the amount of vehicles at the traffic signal, then that system becomes a closed loop traffic control system. In that case, what happens now, if a policeman is controlling if it's not been controlled by the traffic signal, if a policeman is controlling, now what happens? He senses that the number of vehicles at a particular direction has been increased. So, then he stops the other part in the other direction and allows the vehicles in one particular direction to move. So, this is how if we sense the number of vehicles at the traffic signal and then the green and the yellow light and the red light glow, then it becomes a closed loop signal. So, this is some of the example, because control system we are mostly interested in the closed loop control system analysis design of a closed loop control system, because some part or some parameter in the system is being controlled. For example, in any industry it is desired that the particular pressure is to be maintained or particular temperature at the room has to be maintained for the devices or for the equipments to function properly, or in any, for example, in an electronic industry it is desired that the room temperature be maintained at some 18 degrees centigrade. Then in that case we study the control system so that the room temperature is being maintained and what variables has to be changed if there is a change in temperature. For example, from 18 to 18.5. Now, if there is a change, then suddenly it would affect the output of the function, that is output working conditions. Therefore, the immediately temperature has to be changed. Now, when the temperature has to be changed, what parameters has to be changed? So, that is what control system, closed loop control system is all about. These are some of the advantages, that is it is accurate because we are definitely measuring the output and feeding it back to the reference value. The bandwidth is large and also it has it is less affected by noise, in the sense the unwanted signals. Now, in case of open loop system, if this is our input and this is our output, in that case, if there is an unwanted signal, that is W of t, this is an unwanted signal, that is a noise. If an unwanted signal is somehow entering into the system, then the output is affected by this as well as input in case of open loop system. But in case of closed loop system, closed loop system, what happens? In case of closed loop system, this output is fed back to the input in case of closed loop. So, whatever changes in the output occur due to the unwanted signal is also taken care of and that output is being fed. Therefore, here now the accuracy is improved with respect to the open loop system. In case of open loop system, the output response was also due to Wt as well as the input. Now, in case of closed loop system, the output is fed back to the input. So, that has been taken care, therefore, the accuracy has been increased. Here that is why the system is less affected by noise. For example, in a particular room, the temperature has to be the AC has to maintain a temperature and there are only 2 persons in the room. But as now the number of people increases, there are 10-20 people in the room. So, the temperature definitely will not be the same as it was with 2 persons. So, if your AC sense that now this is the temperature of the room and it has to increase the process, it has to change some variable so that the room temperature is maintained. So, that process now becomes a closed loop control system. If the temperature of the room is maintained with the number of people in the room, if there are 10 people or if there are 2 people in the room, the temperature varies. So, such kind of system also comes under the closed loop control system. Now, these are some of the disadvantages, that is obviously because design is difficult and it is more costlier, a number of components have been increased and overall gain is reduced due to the presence of feedback, that we will see over the duration of the course, that how feedback affects the system performance both positively and negatively. And stability, as I said, is a major concern in case of automatic control systems, that will be dealt in time and frequency domain analysis study, and of course requires more maintenance. Now, just simple example to understand what is the difference between a system and a control system. This is a particular fan and the input is the AC supply and there is an airflow. Fine. How is the airflow? Airflow is because of the blades. Now, we can see that a fan without blades cannot be a system, because it cannot provide a desired output. So, what is the output desired? When you give an input to the supply to a particular system, we expect some response. If the response is not there, then it is not a system at all. That is, we are not getting any desired output. From fan, the input is the electrical energy, that is the motor, and the torque is the output, that is the rotation of the motor, and due to the rotation of the motor, the blades rotate and the outflow, that is the airflow, is the output. So, if there is no blades, then there is no output, that is there is no response of the system. Therefore, it has been termed as, it cannot be termed as a system, because there is no response. And now, if there is a response, that is there is a proper flow, there are blades here, then it becomes a system. Now, here we can see that along with the blade, we have a control element as defined here. A fan with blades and with regulator can be a control system, because it will provide us a desired output. Now, if the output is like, we want to change the speed of the fan, that is done through regulator. So, though it is manually done, then it becomes a control system, because now we are able to control the speed, so that the airflow is controlled. So, such systems in which the output could be controlled is termed as control system. That is, the output airflow is been controlled with the help of regulator, that the speed is increased or decreased, that is the current flowing in the windings of the motor is been controlled through the regulator. So, that affects the output. Thus, we can say that the output is controlled with the help of regulator in case of fan, and this is in general termed as a control system. So, I hope in this lecture we are now very much clear of what is an open loop system, what is an closed loop system, or what is actually an system, how we can differentiate whether system is whether we call it as a system or not. So, basic requirement is that there is an input and there is a response from the process, that becomes a control system. The summary of this introduction to control system, because once we get into the technical details, that is block diagram reduction, signal flow graph, time response analysis of first order, second order system, and the frequency domain analysis, both plots, frequency responses, checking the stability, those are all the technical part of control system. But what is the central problem? What is the basic problem in control system? The basic, that is the central problem in control, is to find a technically feasible way to act on a given process, so that the desired behavior, that is the desired process, behaves as closely as possible to the desired behavior. Furthermore, this approximate behavior should be achieved in the face of uncertainty of the process and in the presence of uncontrollable external disturbances acting on the process. So, it is now the simple example of a fan. We the regulation, that is the speed regulation, is possible in steps. It is not that the speed regulation is smoothly obtained. So, if you want something in between 100 rpm to 150 rpm, that will not be possible. Either you get it 100 rpm or 150 rpm or 200 rpm speed. It is not possible something to achieve in between the two speeds. Of course, it is being controlled, the speed is being controlled and the airflow is being controlled, but the phase, that is the difficulty, lies that the given process, so that the process behave as closely as the desired. The desired is now for example 130 rpm. So, the real challenge lies that there is an that behavior should be achieved in the face of uncertainty of the process. Why uncertainty? Because along with the input given, there could be other values which are affecting, for example, the voltage fluctuation, or there is some other resistive element which is changing with time. So, these are all the unwanted signals. For example, if you take a simple bridge circuit which is measuring the resistance, a bridge circuit which is simply measuring the resistance. What are the unwanted signals in case of that? That is the change of resistance over the course of time. So, the unwanted signals are the major concern in case of there lies, that is the external disturbances acting on the process. So, in general, now we have understood what is a control system, classification, open loop and closed loop control system, and in the future classes we will be dealing with the various other topics related to control system. Thank you.